بسم الله الرحمن الرحيم. أبنائي وبناتي طلاب الصف الثالث الثانوي، بنكمل مع بعض أسئلة lesson 2 chapter 1 كتاب المعاصر. السؤال 47 بيقول The opposite figure represents three resistors X, Y and Z زي ما انت شايف. that are connected in parallel متصلين مع بعض على توازي. So which of the following graphs represents the ratios of the current intensity that passes in each them؟ أنا عندي 3 resistors R 2R 3R. طيب أنا عارف اللي دول connected parallel، يبقى ال V constant is the same، يعني Vx بتساوي Vy بتساوي Vz، صح كده؟ طيب وعارف اللي ال V equal IR، يبقى ال R أو ال I equal V over R، صح كده؟ ألاحظ حاجة، إن كلما زادت when the resistance increase the current decreases. When the resistance increase the current decreases inversely proportional، صح كده؟ معنى كده larger resistance smaller electric current. تمام؟ لو أنا عملت graph between the resistance and current y axis and resistance x axis, which one will have the highest electric current? The smallest one, R or 2R or 3R? Sure R. So this is the highest electric current in resistance X, and smaller than it the Y resistance, and for Z because it has larger resistance, so the smallest current. So which graph here? Letter A. Let's go to the next one. The opposite figure represents 3 resistors X, Y and Z that are connected in series. Connected in series means same electric current, right? Same electric current. So which of the following graphs represents the ratios of the potential difference across each of them? You know the potential difference equal IR. R is the same. So for X, Vx equals I Rx. It is only R. For Vy equal I same current times 2R. For Vz equal I times 3R. So which one is larger? Vz. So here is V, the larger one Z, smaller than it Y, and the smallest one X, because the smallest one has resistance only R, the smallest resistance, so and same current, so the smallest voltage. Which answer? So the answer is letter D. Let's go to another one. 49. The reading of the ammeter in the opposite electric circuit is, knowing that the resistance of the ammeter is negligible. So imagine that the current is moving through the 2 ohms. After that, you have 2 resistors connected parallel with the ammeter. But hold on, he said that the ammeter, its resistance is negligible. So the current will prefer to move here and doesn't move through the upper or lower resistors. That's it. So you have the voltage and you know V equal IR. What is the resistance here? R equivalent. R equivalent will be only the two resistors at the beginning at the ending. So 2 plus 3 equal 5. 5 ohms. So I equal V over R equals 12 over 5. It yields 2.4 amps. Do we have this answer? Yes. Let's move to next one. Number 54 lamps, 6 ohm each, are connected in parallel. Then the combination is connected to a battery that has an EMF, electromotive force, 12 volt. The total resistance for the 4 resistors. So you know they are connected in parallel, so 1 over R equivalent equal 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6 means 4 over 6. So R equivalent equals 6 over 4 means 3 over 2 ohms. And you can use other way. R equivalent R over the number, so 6 over 4 means 3 over 2, same answer guys. So the answer is letter C. The basic current in the battery. To get the passing current you have electromotive force, so V for battery equal I, R equivalent, so I equals V over R equivalent equals 12 volts over 3 over 2 means 24 over 3 equals 8 amps. So the answer is 8 amps. Let's go to the third one. The total charge having the battery in 10 seconds. You know well that I equal Q over T. So Q equals IT equals I, 8 amperes times. The time here is 10 seconds. So 10. 8 multiply 10 equal 80. And the unit of a charge is coulomb. So 80 coulomb. For the next one, the passing electric current intensity in each lamp. In each lamp, hold on, the resistors are there and they have the same potential difference. So potential difference for one branch is the same as the battery. So V equal I that pass through any branch times R for one branch. So 12 equals I times 6. So I equals 12 over 6 means 2 amps. So 2 amps move here, 2 amps move here, 2 amps move here, and when they connected together, it is 8 ampere. So we finished this one, 2 amperes. The potential difference between the terminal of each lamp equals same as the potential difference for the battery, so 12 volt. The last one, the total resistance of the 4 lamps when connected in series. So when they connected in series, R equivalent equal N times R equal how many resistors? 4 times 6 equal 24 ohms, or you add 6 plus 6 plus 6 plus 6, it yields the same answer. So the final answer is 24 ohms. Let's move to another one. 51, 2 resistors 18 and 12 are connected in parallel. So the equivalent resistance, so R equivalent, I1 times R2, 18 times 12 over 18 plus 12. 18 plus 12 is 30. 18 times 12, 216 equals 7.2 ohm. So we answered the first part, 7.2. The potential difference between their terminal that makes the total current intensity in the circuit is 1.5. So V equals 1.5 the current times 7.2, it yields 10.8 volts. We have the answer here right there. Okay guys, I hope it is easy. Let's move to the next one. Which of the following graphs represents the relation between the ammeter's reading and the value of resistance S? Okay guys, here is rheostat, right? And the ammeter he spoke about is here, so the current is moving there and divide. But hold on, the voltage between these 2 points is the same exactly as VB, V battery, electromotive force. When you change the rheostat or the resistance S, make it larger or smaller, it affects only the current is moving here to get same voltage as the battery. So for this branch that has the ammeter, it is not affected at all because the resistance here is constant, doesn't it change? The resistance in the branch that has the ammeter doesn't change. So why the current is changing? And you have this potential difference is constant. V is constant and R is constant in this branch. So also the current will not change in this branch. So the right answer will be D, guys. 53. In the opposite electric circuit, the reading of the ammeter A equals. Let's redraw it. This is the battery. Right, guys? And this is the first resistance 6 ohm. And here 6 volts. And there is no internal resistance. And this 3 ohm, we can write it like that. And this is the ammeter. Okay, guys? We didn't change anything. So 3 ohm. You know the voltage here between these 2 points is the same between these 2 points is the same as the voltage or potential difference here or electromotive force. So 6 volts equals I, the current times the resistance in this branch 3 ohm. So the current in this branch that the ammeter is measuring equals 6/3 yields 2 ampere. I hope it is easy, guys. Let's move to next one. 54. In which of the following electric circuits the intensity of the electric current which passes in one of the 2 resistors differs from the other resistors? So which one from these 4 circuits have different currents in one resistor than the other? At the beginning, let's see letter B. As you see, they are connected series. So only one path for the current. So same current is moving here. So this is not working. Also this one, because the resistance here are connected in series. So same current. Let's see this one. These resistors are connected parallel, but hold on, the resistance upper is exactly the same as the resistance in lower branch. And you know well that the voltage here in the upper branch exactly equal the voltage here in the lower branch exactly equal 12, the electromotive force. So the current in the upper wire exactly equal the copper, the wire, the current in the lower wire. I hope you got it. So it is not working. Let's see letter E. When the current here divide, you know well the potential difference is the same. But as you see, R here is different than in the upper and lower, in the upper and lower wires. And we can calculate it, but the answer this one. You know why? Because the current is different, because they are connected parallel, and so there is and the resistance not equal, so the current is different. To calculate the current in the upper wire, 12 volts equals 6 times I1. So I1 equal 12 over 6, 2. To calculate the current in the lower wire, so 12 equals 4 times I2. So I2 equal 12 over 4 equal 3 amps. As you see, the current is different. Let's go to the next. 55 in the electric circuit shown in the figure, the reading of the voltmeter is 4 volts. So the reading here is 4 volts. Then the electric current intensity that passes through the 6 ohm resistor. He needs the current that moving here. At the beginning, you can get benefit from having the voltage here, because for this resistors 2 ohms, V equal IR, so 4 equal I times 2, so the current equal 2 ampere. But hold on, this current is divided to I1 and I2, so I equals I1 plus I2, so I1 plus I2 equals 2. Let's have you know well another thing, the potential difference between these 2 points is the same, right? So I1, R1, we call it 6, equals I2 times 4. So what do you need? I2, right? So let's get benefit from this. I2 or I1 equal 2 minus I2. But hold on, which current you need to get? The current that move in 6 ohm. So you need to get I1. So make it I2 equal 2 minus I1. And use it. I1, 6 I1 equal, instead of I2, 2 minus I1 times 4. So 6 I1 equal 8. 8 minus 4 I1. So it goes on the other side. So add them, 10 I1 equal 8. So I1 equal 0.8 amps. I hope it is easy, guys. I hope it is easy. And also something, you can get the current that moves through the lower wire. It equals I2 equal 2 minus 0.8. It yields 1.2. And 1.2 plus 0.8, it gives you the whole current. I hope it is easy, guys. Let's move to the next. Number 56 in the electric circuit shown in the figure, the ammeter reading equals. Look carefully, guys. As you see here, the total current I move in this resistance 18. What happened after that? It will divide. It will divide for the upper and lower wires. What is the resistance here? It is 12. What is the resistance in the lower wire? Exactly 12. 9 plus 3 series it yields 12 ohm. So the current that will move in each the upper wire or the lower wire exactly equal half of the main current. If the main current that moves through 18 ohm is I, so the current will divide in the upper and lower wires. So I that the ammeter will measure equals the current equal I over 2, half the main current. So I over 2, the answer is letter B. You know why? Because the resistance in the upper wire exactly equals the resistance in the lower wire. I hope you got it. Number 57, in the electric circuit shown in the figure, the electric current through the battery becomes minimum value when closing switch. Current is minimum when resistance is maximum, right? So about key number 1, so we need the maximum resistance, guys. When you close key number 1, what will happen? The current will move here. It can't move through 2 because it is broken. So it moves this direction, and the resistance is only R because this switch and the other opened. So resistance R. Let's see key 2. Let's close key 2. Key 2 is here. So the current will not move in this direction, will move directly through this and return back. The resistance here are, the resistance here are connected series. So the total resistance equal 2R for key 2. Look carefully. Key 2 is here. So the current move there and return back, right? It cannot move through here or there. Let's see key 3 when it is closed. Key 3, close it. The current will move this direction and the resistance only R, right? So let's try key 4. Switch off. Key 4. So the current will move in this direction and there is no resistance. The resistance only for the wire because there is no other direction it can move through. It cannot move through here. It can move up. So the only way when you close this switch, return it back. So the resistance is minimum. He needs the minimum current when you have highest or largest resistance. So key number 2 is the right answer, guys. Let's move to the next. Number 58, in the opposite electric circuit, the total resistance in the circuit equals. Look carefully, the current is moving here and start to divide, right? So in the lower branch you have 5 and 5 and means 10 ohm, and you have here in the middle wire 5 ohm and the upper wire here 10 ohm. And this, when the current return back, it will move the whole current through this resistance. The whole current mean this resistance is connected series. So let's get the resistance. At the beginning, 1 over R dash equal 1 over 10 plus 1 over 10 plus 1 over 5. The 10, the last thing we got it from here. 5 plus 5 because they are connected in series. So times 2 means 4/10, means R dash equal 2.5 ohm, and you have another resistance is connected series, so R equivalent equal 2.5 plus 2.5 equals 5 ohm for the whole circuit. About B, or the second equation, the total current intensity in the circuit equals the total current intensity. You have the electromotive force V equal I times R equivalent, means the voltage 15 equals I times 5, so the current equal 3 amps. So 3 amps. Okay. The last one, the potential difference between A and B. Between A and B, you got the total resistance between A and B for the 3 resistor 10, 5, and the last one 5 plus 5, 10. So V equal the whole current times the R dash, means 3 times 2.5 equals 7.5 volts. 7.5 volts, we have it. Let's move to the next. Here in 59, from the opposite figure, the ratio between the voltmeter reading V1 and the voltmeter reading V2 equals V1 connected with only one resistance, right? So the whole current will move through R. So for V1 equal I R, right? For V2, the current will divide exactly half of the current will move through the first resistance and the other half will move through the second resistance. So when you calculate V2, the current here I over 2, because half of it will move through each branch, times R. What he needs? He needs the ratio between the voltmeter V1 over V2. V1 IR over I over 2 times R. R goes with R, I goes with I. 1 over half equal 2. So the answer is 2. Let's move to the next. In the opposite electric circuit, the ratio between I1 and I1, the main current, I1 that moves through the upper right, make this I2. So you know well that I equal I1 plus I2. And also I2 equal I minus I1, right? But the voltage, the potential difference in the upper right, in the upper wire, exactly is the same as the lower wire. So V1 equal V2, V1 I1, R1 equal I2, R2. R1 is 4 ohms because 2 in series. So I1 times R1, 4, equals I2 equals I minus I1 times R2. R2 is 2. So 4 I1 equals 2 I minus 2 I1. It goes on the other side. So 6 I1 equal 2 I. What he needs a ratio between I1 and I. And hold on. So divide by 2, 3 I1 equal I. So I1 over I1 over I equals 3, and the ratio doesn't have any unit. So the answer is 3 or 1 over, 1 over 3. You can do it, guys. divide by 3i over 3i. I goes with I goes with I, right? And 3 goes with 3, so I1 over I equals 1 over 3. So the right answer 1 over 3. That's enough for today. We'll complete the rest of the question in next videos. God bless all of you guys. كان معكم Mr. إبراهيم سلطان Physics and Chemistry teacher. لا إله إلا أنت سبحانك إني كنت من الظالمين.